Alright, let's look at the function that's on the screen there. F of x is x cubed plus 2x squared minus 4x minus 8. I want to start by talking about the end behavior of this function. Now, all of the functions on the handout that you looked at were monomial functions. They were polynomials, but there was just one term. So if we look just at that much of the function, you should, I hope, be able to predict that the right end behavior is going to go up and the left end behavior is going to go down. All right. Well, here's the deal. Let me get this out of the way. Delete. There we go. Okay. When you have a polynomial function, the end behavior is always going to be dominated by the leading term. So you can look just at the x cubed and predict what the ends of this graph will do. Now the next thing I'd like you to do is find the zeros of the function. Remember that happens by setting the equation or setting the function equal to 0 and solving for x. And this, in a lot of cases, factoring is going to be what you want to do. So we're going to factor by grouping. We can pull out an x squared out of the first two terms. And then looking at the next two terms, a negative 4 can come out. Now we have a common factor of x plus 2. And the other factor is x squared minus 4. You're not quite done. X squared minus 4 is the difference of squares. And that will factor as x plus 2 times x minus 1. Now you can write that as x plus 2 quantity squared times x minus 1. Now, if we're finding the zeros, you're going to set each of your factors equal to 0 and solve for x. So I'm going to work with the factors all separately, and I get x is equal to negative 2, x is equal to negative 2, x is equal to positive 1. When you have a 0 that's repeated, okay, we've got negative 2 is a 0, but it's a 0 twice. Sometimes this is referred to as a double 0. Or in the context of what we're doing today, we need to talk about that 0 having a multiplicity two. When you've got a 0 that's only a 0 one time, we say the multiplicity of that 0 is 1. So the multiplicity of the 0 basically indicates to us how many times is that number a 0 of our function. Now, what I want you to do next is take a look at a graph of this function. I've already got it entered in my calculator and the viewing window set up so it's going to look nice. So let me go ahead and graph that. Okay. Get the calculator out of the way here. Move, calculator. There we go. Okay, zeros tell you where the x-intercepts are. So we have an x-intercept at negative 2 and an x-intercept at positive 1. Now what I'd like you to notice is, well, before we get into that, also notice that our end behavior was correct. The right end goes up, the left end goes down, like we expected. Right end goes up forever, left end goes down forever. Okay. So what's different about those two x-intercepts? Well, the curve does not cross the axis at negative 2. It touches the axis at negative 2 and then kind of bounces off and turns around. We do have at x equal 1, the curve does cross the axis. Well, here's how that works. Anytime you have a multiplicity that's even, your curve will not cross the axis at that 0. When the multiplicity is an odd number, the curve will cross the axis. So when you have even multiplicity, the graph touches the axis and and turns around or bounces off. So the way I like to talk about that is I like to say that the graph bounces on the axis there. Or let's just call that a bounce. If you have odd multiplicity, the graph will cross the axis. Every time. So, when you're sketching the graph of a polynomial, the first thing I want you to think about is end behavior. Okay, remember that the leading term indicates what the end behavior of the function is going to be. The second thing that you're going to do is find the zeros and their multiplicity. Okay, so when you do that, you're also going to determine if you have a bounce or a crossing or a cross at each 0. Okay, the zeros are the x-intercepts, so you're talking about what's going on in the x-axis. The other thing that you need to find is the y-intercept. In other words, plug 0 into your function and figure out where that curve's going to cross the y-axis. If you've got the places where the graph's going to cross the touch the x-axis or cross it, the place where it's going to cross the y-axis, and you know the end of behavior, then you're going to be able to sketch a reasonable graph.